Hi! Today we're going to learn about improper integrals and calculus. And this is the Improper Integrals 2 video. So, here's where we have an integral where one of the bounds is infinity, or two of the bounds are infinity. So how do we do this? In this example, the upper bound is infinity. Now we know that we can't take the integral from a lower bound of 1 to an upper bound of infinity. Can we? Or how do we do it? Well, here's where we go back to something that we learned in the very beginning of calculus: limits. So we could say that this integral would be equal to the limit as, let's say, n approaches infinity of, let's lower this down to get some more space. This would be equal to the limit as n approaches infinity of the integral from 1 to n of 1 over x squared dx. So now, because we actually have an upper bound that isn't infinity, it's a variable, or it's just a place holding variable, we can compute this integral. So we know that this integral would be, this would be equal to the limit as n approaches infinity of this integral calculates to negative 1 over x from 1 to n. So now let's go ahead and plug in our values. So we get, and this would be equal to the limit as n approaches infinity of negative 1 over n minus negative 1 over 1, which is minus negative 1, which is plus 1. So now what do we do? Well, here's where we can just plug in our n value into the denominator, because we know that because of this, if we substitute n in, or the value of n in, then this still remains a value. So it's not dividing by 0 or anything. So we can just substitute the value of n in. And remember that this is a limit. So we get 1 over infinity plus 1, or negative 1 over infinity plus 1. So we know that a number over a really, really big number is just getting close to 0. So this would be equal to 0 plus 1, which is equal to 1. So the area under the curve of 1 over x squared from 1 to infinity converges to 1. Today we learned about improper integrals 2 in calculus. Thank you for watching this video.